take a car and slice it in half. The top half is the more customer-facing, consumer-related applications around e-cockpit IVI. And then there's the bottom half, which is the important controls functions in the vehicle that control the drive, control the steering, control the aspects of the physical vehicle itself, where the top half relies on the process of updating, the cadence of updating is very, very different between the top half and the bottom half.
Green Hills Software is a worldwide leader in embedded safety and security, with hundreds of millions of vehicles running software created with Green Hills Automotive Solutions. Green Hills safety certified real-time environments, embedded virtualization, and advanced development tools lower development costs while reducing time to SOP. For the latest in software-defined vehicle solutions, visit www.ghs.com. Hi, my name is Junko Yoshida. I'm the editor-in-chief of the Ojo-Yoshida Report. Today we have a special guest from Green Hills Software. We've got Dan Mender, Vice President of Business Development at the company. So hi, Dan. How are you?
Hello, Junko. I'm doing great. Thank you. Glad to be on your podcast.
Yeah, well, thank you. I was actually really looking forward to have you because since you and I first met, I think we first met in Munich, right? And I have been curious about really the role that companies like Green Hills, which my understanding has been always deeply embedded in things like vehicles and the other things as well, how you guys actually can help of this big movement automotive industry is about to embark on software-defined vehicle. That's why we wanted to have you.
Well, yeah, I think it's definitely important to have a software company talking about the S in software-defined vehicle. So we're certainly looking forward to giving you our perspective, our experience, and our understanding of where things are today, where they're heading, and what's needed to achieve the vision and goals of what software-defined vehicle means. So looking forward to the discussion.
All right. Well, let me ask you, I'm going to ask the first question when did you actually hear the terminology software-defined vehicle first? How many years ago was that?
Well, actually, if you want to know the truth, it was in 2006, and I was doing a presentation at an automotive conference, and I used that term, and I could even bring up my presentation to show that. But it took a while to take. But
yes,
we've certainly been discussing.
After all.
Yeah. So from a perspective of software defined, we've been using that term for quite some time. Initially driven by some of the flexibility and scalability we were delivering with some of our hypervisor technology that we developed, back in that time frame. So, yeah, we've been using it for quite some time, and then larger companies with a little more marketing efforts than us started using the phrase, and it's stuck.
All right, very good. So, having been kind of one of the pioneers of software-defined ideas in vehicle, tell me, how do you define a software-defined vehicle then, and has it changed for you?
Well, back then we were discussing how you would use, software architecture to deliver scalability and portability and flexibility in your system designs. It was originally focused more in the IVI system. There was no ADAS back then. The software-defined aspects of creating a IVI, which is then turned into an e-cockpit.
Right.
But it's certainly evolved since then to become something much, much broader and more complete.
Right. All right. Very good. When we first, you and I started talking about it, you mentioned something interesting. You said Junko, back in 1990s, people started talking about, downloading a new operating system into Windows computer, and that was actually a big deal, right? Every time Microsoft came up with a new OS, people lined up and started to download the OS to see how your computer changes. Now, that was then, and that was for computers. Here we are in vehicles. So this is a very kind of an embedded system design 101, but humor me. Explain to me how the RTOS used real-time operating system used in vehicle, and actually, I guess you can actually upgrade the RTOS. How is that different from the back in the days of the operating system, PC operating system upgrades?
How about PC or mobile phones, right?
Yeah,
I think
exactly.
there's a PC Patch Tuesday, and there's also my mobile phone. I wake up in the morning and it's been updated automatically, right? But
Right.
if you take a look at the differences in the devices, a PC or a mobile phone has a single operating system, and it's a single operating system holding many different applications. So it's a it's a lot less complex than what we're dealing with today's vehicle architectures. So today's vehicle architectures, if you take a step back and look at what is the definition of a software defined vehicle today? What is it? What is it? And the way at least the way I look at it is I take a look at a software defined vehicle as two halves. If
Okay.
you take a car and slice it in half, the top half is is the more customer facing, consumer related applications around e-cockpit IVI,
Right.
and that's you can think about that as one big box of functionality. And then another box is the ADAS or autonomous drive functionality
Yeah.
that is also consumer focused, giving the types of features and capabilities and solutions that are available today. And then there's the bottom half, which is the important controls functions in the vehicle that control the drive, control the steering, control the aspects of the physical vehicle itself, where the top half relies on. And if you look at it from those three perspectives, there's many different operating systems. On the top half, it's very consumer oriented.
Right.
I've got Linux operating systems, I've got Android operating systems, I've got to follow various processes to upgrade to certain versions on a certain cadence if I'm doing an e-cluster, and maybe even IVI or the ADAS if I'm using something like an Android, let's say. But down below,
Yeah.
it consists of much more of the real-time and safety operating systems.
Yep.
And the process of updating, the cadence of updating is very, very different between the top half and the bottom half. So it's a very complex. So you're not going to ever really update the whole vehicle at once. You may update at once all three of those main areas of the car,
Right.
but each one has their own
Uh,
dynamics of upgrade, application functionality. At the lower half, you have to consider the implications to safety certifications that may have been done for the lower control systems and making sure you're not impacting that. Where above, you don't have to worry about those types of things. So
right.
it's definitely a lot more complex. But
Yeah.
I see the car as three main areas and the car broken in two halves.
Okay. And what are the three main areas you mentioned? You mentioned the
E-cockpit
e-com.
IVI,
Yep.
ADAS autonomous,
Yep.
and then vehicle controls.
Control. Okay. Good.
Right.
So, even actually top, I really like the analogy of, splitting the car in two, right? That's really easy to visualize. But even on the top part alone, you mentioned, not one, but several operating system, right? So altogether, top half, bottom half, how many operating systems do you have?
Oh, dozens.
Dozens.
Dozens
Holy
of operating
cow.
systems. And especially in the next generation of vehicle architecture where software-defined vehicle will take advantage of these next generation multi-core high-performance microcontrollers and new SoCs that are incorporating both the application cores and microcontrollers. Even the SoC itself is going to have 20 CPUs inside the SoC.
Oh,
And if I have 20 SoCs, if I have 20 processors inside an SoC, I also have the ability to run multiple OSs on each processor.
there you go.
So you can
Wow.
quickly see how the number can grow.
Okay. All right. All right. So now I understand sort of gravity of the situation that it's not going to be just a one, shot, mobile operating system upgrade overnight. I get that. Now, from what I understand though, there are, layers and layers of software inside the vehicle already. I mean, you already mentioned the infotainment, or aka cockpit, ADAS system, right? But there are software that connects to the cloud, and the software connects to the vehicle. Software connects to, I mean, the software. There's just so many layers of software, right? And tell us that where Green Hill software sit in all those different layers of softwares. Do I mean, I assume that some of the software layers you actually create, but you are more of a glue to different softwares. Can you educate me on that?
Yeah, glue, or you can think of it as foundational.
Hmm.
Uh, our focus at Green Hill is to deliver um, a common software foundation and platform of safety certified real time operating systems and safety certified hypervisors that can run on both the real time CPUs that are the safety CPUs or the safety islands. They're the ones that are doing the vehicle control, and also on the application cores. So these are the processors that are running the e-cockpit and IVI and ADAS. So having the safe and secure foundation that can host the critical safety or security applications and services and functions, and also have a solution that can host generic high-level OSs like Android or Linux,
Ah,
and keep that separated and support mixed criticality and freedom from interference, both on the real-time processor side and the application core side. We're
yeah,
a unique, uh, company
yeah,
in the embedded software market where we're the only one that can deliver complete solutions on both the real-time cores, which are mostly found in that bottom half,
right.
and then um, foundational software that can run on the top half, hosting the generic functions of
Too.
high-level OSs, and provide a single development environment that can help you visualize
Yeah,
the complete system behavior inside each of these modules.
yeah.
It gets very complex where you have multiple CPUs running multiple operating systems with a range of different applications. And having the responsibility to integrate and make that all work is extremely challenging.
Yeah, no, that's a very good point. So the all those different layers of software you just laid out, right? Um, they're already in there today in today's vehicle. Now, fast forward to the software defined vehicle. How is it going to change? You mentioned actually a couple of minutes ago the one processor unit could have like 20 different SOCs, or the other way around, I guess. There's different cores inside the chip, right? That means actually it's integrating certain hardware and software functions on the same chip. So the software defined vehicle, the way I understood it, is that it's the integration both hardware level and software level. If that is the case, how that movement through the software integration or SDV changes your pieces of software, or or it's going to be just the same. You sit at the foundation level, you do nothing, or how will that change?
I wouldn't say so much that our software changes. What we're able to deliver to our customers is an enablement to be able to support this transition.
Ah,
So today's vehicles, and still today's vehicles, have 100 ECUs in your traditional typical OEM architecture. There's many ECUs, and most of them are still individual functions. So there's efforts going on with all the OEMs to do some proof of concepts and prototype the proper steps to consolidate those individual ECUs into a smaller number of ECUs.
right.
Can you take 12 ECUs and move them into one? Or do you have to do it in two? We're working with the OEMs to help them sort some of that out today, where you have these individual ECUs,
Mhm.
and some of the challenges of consolidation is running them in a way that they expected to run when they were individual, but putting them next to another ECU inside more from a software perspective, and doing it in a way that they both behave in the same way they did when they were individual, but provide the guarantees of freedom from interference and the guarantees of independent and unobstructed execution. So I've got ECU 1 and 2, they're separate, and now I'm going to the new software-defined vehicle. I'm going to bring those two together in a single ECU, but I want them to behave the same way they did, and I want them to be executing in an independent manner and not be affected by the behavior of anybody else in the system. So it's a unique challenge where you've got to make sure you're incorporating the right architecture for hosting separate and independent
Yeah.
services and functions, whether they're classic AutoSAR or something else, multiple instances of classic AutoSAR. How do you do that? How do you do it effectively? How do you boot that complex system? How do you guarantee the freedom from interference and separation? How do you guarantee the amount of CPU and memory an individual ECU from a software perspective needs to run? So there's a lot of different aspects that you have to enable for somebody that's developing that complex integrated system that you didn't have to have before. Before, when I was running in a single ECU, I owned the CPU, I owned the memory, I didn't have to worry about anybody else.
Right.
Now I've got a lot of playmates in my ECU, and I got to make sure they don't affect how I'm running, how I'm executing. I'm executing my critical functions,
Yeah.
and doing that in a way that can be debugged and optimized.
Interesting. So in a way that it's really culprit here is shared resource, right? I mean, we have a couple of different software sharing the same hardware, as you mentioned, CPU, memory, and other things inside the chip, and how you play well each other, but also does not damage, does not interfere with other software. Now, when people
Well,
do that, yeah,
But let me just, when you talk about sharing, let's talk about the word sharing.
okay,
So those different functions are absolutely sharing resources inside the same CPU or
right,
SoC. But it's Greenhill's job to make sure that from an access perspective, things aren't shared. So you're integrating and executing individual software functions,
yeah,
but our architecture and our products guarantee that if one ECU needs a certain CAN bus, that it gets access to that CAN bus and nobody else sees it or can get access to it. So that CAN bus isn't shared; it's dedicated. So our job is to bring these together and quote share all the resources that are in a CPU, but from a system architecture perspective, guarantee that what an individual ECU needs is assigned, and only that virtual ECU has access to it and will benefit from that memory or that CPU or that physical bus or whatever it might be.
Wow. So you actually go down deep into the SoC to make sure that the software kind of doesn't interfere each other. In other words, I guess what you're saying though is what I'd like to understand. If, say, for example, I'm a chip company, right, and I designed a really new, super integrated chip, and I'm very proud of it, and I want to run not just one application, several applications. Do I come to you and ask you how should I architect my SoC, or how should I change my software to run on this multiple software in the same my super duper new SoC? How do I work with you?
My answer is 100% yes. You definitely come to Green Hills. It's interesting, as systems get more complex.
Yes.
The unique expertise and value that Green Hills has becomes more important as the systems become more complex. So, if you look at these complex SoCs, so thank you to all the SoC manufacturers for making these complex multi-core SoCs, because it takes advantage of the operating systems and hypervisors and development tools that we've developed specifically for this use case on your SoCs. So you have, when you start consolidating multiple functions in a multi-core system, there's certainly the hardware pieces that help facilitate being able to do that, but you can't effectively do that until you add the right combination of software with the SoC. And that's becoming more important as these more complex multi-core SoCs become available. So you can dedicate, here's an example.
Yeah.
Let's say I have, in the past I had, I get this new SoC, and this new SoC has 16 high performance real-time microcontrollers on it. Okay. So I'm excited because I can take 16 physical ECUs, and I can assign each of the physical ECUs virtually to one of the 16 CPUs in my SoC. So, that's the idea, that's the concept. Mm-hmm. But the single individual ECU that it's coming from is a pretty low performance, low clock speed individual CPU, and I'm going to take this function and I'm going to move it over to, as an example, a 1 gigahertz processor. So now I'm going to take this ECU function, I'll move it over to this high performance CPU, and I'm only going to use 5 or 10% of the CPU. Yeah. So I'm going to take and have 16 different virtual ECUs running, but I'm only using 10% of the processor.
Right.
So where Green Hills comes into play is we have hypervisor capabilities that can run across the processor, those high performance processor cores, where you can assign the percent of CPU. So I can take a single gigahertz CPU, and I can run 3 or 4 virtual ECUs on it. And I can assign the amount of CPU I need. I know I need 10% for this one virtual ECU, I need 30% for this other one, and I need 30% for this other one, and I've got some spare for flexibility and portability in the future. So we're by combining Green Hills solutions with the next generation powerful multi-core SoCs that are out there, we're delivering that scalability and flexibility that is the definition of software-defined vehicle. The ability to be able to move things, to have the portability and flexibility to move applications within the ECU itself, or to move it to other ECUs within the vehicle architecture. So these are the important things to be able to enable.
Yeah. That's kind of mind-boggling when you think about it, because it's, if it is one-to-one, one ECU, one application, that's a simpler world. Now we're talking about really the web of available processing power and available memory, and I guess available interconnects. I mean, this is getting super complicated. And the more I talk to people who are in the SDV, software defined vehicle field, um, I think they're beginning to kind of fess up. It's not like when I started this podcast, I thought the SDV is already here. Yeah, maybe, if you're only talking about OTA, over the update. But in reality, SDV, I asked one of the guys, and if there's an SDV mountain, where are we? Are we like halfway there? And one guy said, no, we're at the very beginning. Or somebody said, we haven't even been to the base camp yet. We are just figuring out what tools to bring to the base camp right now. What is your assessment of that?
I will agree. If we take the analogy of still being at the base camp, I agree with that. Yeah, 100%. Where we're at right now is, you can think of the OEM. The OEM is at the software-defined vehicle version of REI, and and they're surveying and taking a look and understanding what type of equipment
Yeah.
they want to bring into their they're climbing the mountain. What's best suited to help them climb this mountain faster with the least amount of pain, the most flexibility, and get there in a faster time to market and a lower cost. So that's really kind of where we're at. Where in working with the OEMs and
Yeah.
working on some of the POCs,
Yeah.
they're still trying to sort out what type of equipment
Yeah.
is going to be the best equipment to help them
Wow.
realize what they want to do. And in some cases, we're helping them understand what they should be thinking about realizing.
Mm.
It's a very challenging, complex problem where you need to bring subject matter experts in to talk about, what could be possible, what is possible, what's feasible,
Right.
what's not feasible, what are some of the challenges. We've been doing embedded software for over 40 years. We've seen lots of systems, lots of complexity, lots of challenges, and we can certainly, and we do, bring a lot of lessons learned with our subject matter experts to the discussion on how you can solve problem. It's Green Hills. We're not just bringing, a portfolio of products that help enable that consolidation, that mixed criticality consolidation. We're really bringing, many decades of expertise on solving complex, difficult problems, just like what the automotive industry is facing.
Yeah.
Consolidation like this isn't new. This consolidation of ECUs started in 2000. The first industry to do it was avionics. Because of you think about an airplane.
Yeah.
What's one of the most expensive costs to having an airplane? It's the fuel.
Yeah.
So if I can reduce the space, weight, and power of the electronics, I can be much more fuel efficient. And I can use less fuel to go the same distance. So I'm saving cost. I can put more passengers in. There's lots of things I can do.
Right.
So we've been delivering mixed criticality integrations like this, where you're consolidating critical and non-critical functions in a single ECU.
Yeah.
We've been doing that since 2000. So we've got a lot of lessons learned and understanding on what it really means to deliver separation, how to verify and guarantee that there's separation and freedom from interference in an architecture, not only just from a software perspective, but also from a processor architecture perspective. how do things like processor cache and sharing devices and all these things that they're not sexy,
Yeah.
right? I wish Green Hills did more sexy things, but we do the hard things. We're not doing cool,
Yeah.
3D graphics that are flying around the screen, but we make sure that they run and they don't fail.
Yeah.
So, we understand and do the really hard parts and the foundational parts of what software-defined vehicle needs.
Yeah. Interesting. So, as I talk to more people, it looks like it's not just one company who can do everything, right? I mean, Green Hills obviously plays this, as you said, mixed criticality areas, but it's like, who do you see in the ecosystem? How do they have to work together? Are we there yet? I mean, can you tell me a little bit about ecosystem around software-defined vehicle?
Yeah, that's 100% correct. It's not. It really is a consolidation and integration of multiple partners from various expertises and disciplines. So it's a mix of both hardware. So when I say hardware, I'm thinking of the high performance SoCs, manufacturers. I'm thinking about the software providers, both operating systems and middleware. And when I say operating systems, it's usually not Green Hills, but also classic AUTOSAR vendors like
Right.
Vector, Electrobit, people like that. And then the middleware providers, middleware / tier ones. Because the other thing that's happening in the software-defined vehicle direction
Yeah.
is the ecosystem and the inner workings of the ecosystem with the OEM is changing. In the past, it was the OEM would rely on the tier one would make all the decisions, they do all the integrations, and the OEM would write the specs, and that was it.
Yeah.
Today, especially with today's software-defined vehicle, the OEMs are taking on much more of the, not only writing the specs, but the responsibility of working directly with the new class of partners, new class of tier ones and tier twos. So, Green Hills directly, or different tier ones that are more software centric and not just hardware centric. So you've got that going on too. So it's not just the fact that there's multiple partners or multiple pieces to the software-defined vehicle puzzle that need to be integrated. It's also the relationship and how it's evolving with the OEM differently than it was in the past.
Yeah.
So, we've got some real-world examples today where if you take a look at that half of the vehicle again, the one area of the vehicle, the bottom half of the vehicle, is less mature when it comes to delivering platform solutions. If you look at, eCockpit IVI, there are companies that deliver complete SoC, OS, middleware solutions. ADAS, the same thing. On the lower half, the controls, the foundational side, it's still very individual and scattered. So we've been working to address that with one of our silicon partners, NXP, and we're working with them to deliver the car functional. So the car functions, the control functions of the car, where at a high level, we're looking to abstract the whole integration and aspects of vehicle control to an API that an OEM can just write their classic AUTOSAR or adaptive AUTOSAR applications to, and all the integrations of operating systems, hypervisors, classic AUTOSAR, adaptive AUTOSAR, some IP, extraction layers, APIs, it is all done in a way that's production software focused, so that the OEMs can have a platform that they don't have to spend the time and integrate. And it's, as we've gone through this exercise, we have definitely understood the pain that the OEMs or tier ones have gone through in trying to bring multiple vendor solutions together. So it's not just having So you're right. There's multiple ecosystem partners that are important to evolve and help realize software-defined vehicle.
Yeah.
But it's also how that gets delivered to solve the problem.
Yeah.
It can't be individual anymore. It
That's
needs to be
right.
done more from a solution focus.
Yeah.
And when we met in Munich, that was one of the things we talked about was the efforts that NXP has put together to create the open platform around S32 Core Ride, and it's delivering the production focused integration. So thinking about safely and securely consolidating separate mixed criticality functions across real time, AUTOSAR, POSIX, open source operating systems, integrating production focused solutions so the OEM can focus on their differentiating features.
Yeah.
Also delivering a very important thing that's really not talked about much, and that's we need to have a transformational change on how this type of software is debugged and integrated and validated and optimized. So from a Greenhill's perspective, we're bringing a single integrated environment that in that complex system that I just talked about that has multiple operating systems and hypervisors, we have a single instance of a single debugger that can debug all the cores and all the operating systems. And that's very different. It's very important and very different because, as I mentioned, the OEMs are changing their relationship with their ecosystem partners.
Right.
They're also taking on more responsibility in the code development, the integration, the validation, and test. And one of the reasons they're doing that is because before they did that, they would get a lot of black box components in from their suppliers. They'd be responsible for bringing them together and putting them in the car.
Yeah.
And then when there was something that happened that was unexpected, they really didn't know why it happened, where it came from, and who to really go to help fix the problem. So they would bring everybody in. They say, okay, you 30 suppliers, I want you guys in this room, and I want you to figure out who is the bad actor and fix it. And you can't leave until you're done. I mean, that's no way to run a business. That's not efficient. That's not effective. You need to truly be able to quickly understand, visually see and understand the behavior of your system and find that bad actor, find that bad behavior, and focus on it and fix it. So those are other areas that we're focused on and bring a subject matter expert to the problem.
No, that's actually quite important, right? I heard a lot of nightmarish stories about the OEMs putting all these people together in one room, and everybody kind of like, well, I understand my portion, but I don't know what my part affects the others, right? I mean, not a single person has the knowledge of the entire system. And what you're saying is that some of the debugging and some of the software can alleviate the potential problems in advance. Is that what you're saying?
Right. You need to change how you need to update and enhance your processes and techniques that you're currently using today to develop, debug, and optimize your software and integrate your software from a vehicle architecture perspective.
Yeah.
So, remember I mentioned there's, dozens of operating systems. Those dozens of operating systems are running hundreds of applications throughout the vehicle.
Yeah.
So I don't know if you've ever heard of a debug technique called printf. Have you ever heard of that?
No.
Okay. Well, it's the lowest, least capable way to understand what's happening in your system.
Okay.
And it's still a technique that's being used in the automotive industry as a way to try and understand the behavior in your system. And I can guarantee it's it's not effective. Not effective. There's no reason to do that. There are many ways that you can collect the behavior of your system, visually view the behavior of your system, time synchronized across all the cores and OSs. And when you see, because visually is an interesting thing.
Yeah.
Printf is all textual, so you get this big print off, and you have to kind of guess what happened.
Oh.
And the only person that can guess what happens is your guru.
Yeah.
And every company has their one guru that has to try and solve the problem. So by being more efficient and effective in how you're debugging, integrating, and optimizing code in these complex systems, you can make everybody a guru. You can make everybody much more efficient and effective.
Yeah.
And you can see the behavior, and you can quickly see that behavior wasn't correct, and then you can point down to it, and you can then dive down deeper and deeper and really see what happened.
Oh, wow.
So the visualization of how something's working is very critical and important to the system.
It becomes even more important than ever before as a vehicle becomes software defined.
Yeah, I mean, most times when somebody writes an application and they're writing the code and they expect it to do A, B, and C, and this is how it's going to work, and then they run it and they see it visually, and it's like, well, that didn't do what I expected it to do. So they go and change it, but that's what you're dealing with, and
wow.
So we've got lots of areas of knowledge, mature expertise around the techniques and processes to properly integrate mixed criticality systems. Wow. We have assets around operating systems and hypervisors for real-time and application cores, and we have the advanced debug environment that can make the process of realizing software-defined vehicle much more efficient.
Interesting. This is actually very interesting. This is the first time during this series of podcasts we have done, we have gone down deeper into this, how the software development environment itself needs to change in order to accommodate the complexity of the software and hardware bringing into the software-defined vehicle. This is very interesting. Thank you very much, Dan. This was we could spend another hour talking about this, but I would like you to come back. But thank you for coming to the.
I'll talk for another. Yeah. No, that's great. No, I really appreciate the opportunity. It's a topic that needs to be brought to the forefront, and we're very happy to be the face of software in the software-defined vehicle space.
All right. Well, thank you very much. We've got Dan Mender from Green Hills Software. Thank you very much. Talk to you soon.
Thank you, Junko. Okay,
Bye.
Take care.
Green Hills Software is a worldwide leader in embedded safety and security with hundreds of millions of vehicles running software created with Green Hills Automotive Solutions. Green Hills safety certified real-time environments, embedded virtualization, and advanced development tools lower development costs while reducing time to SOP. For the latest in software-defined vehicle solutions, visit www.ghs.com.